Hi, I'm Rolf from Waldorf, and this is Protein. Protein is our new affordable polyphonic wavetable synthesizer with 8 voices and 4 layers. It's a new design, but it goes back to the original sound of the microwave released in 1989 with its famous 8-bit ASCII oscillators in all the classic microwave and PPG wavetable set. We are running those oscillators in 250 kHz original sample rate to get all the beautiful dynamics, aliasing, and 8-bit quantization of the original. This is a deep dive video. If you're looking for sound examples, please check our YouTube channel for the respective video. In this video, I will explain a bit of the features and the background, why we have done it, and why it's done that way. It's the Waldorf way. It's the microwave way. In a modern, small form factor, it's a Protein. So let's get started. We have 2 oscillators, both going back to the original microwave ASIC chip. This chip runs in 250 kHz and run 8-bit wavetables, partly from the original PPG and own ones. We have all the microwave and PPG wavetables in the Protein, and we have 2 oscillators. And in contrast to the original, both oscillators can have a different wavetable. So it goes back to the original sound, and we modeled not only the original 250 kHz sample rate, but also the digital to analog converters used in the original microwave, and the unique noise generator in the ASIC chip. So let's have a listen how that sounds. We are just doing an init sound, like this, and I just play the basic wavetable. It starts with a sine wave, which in the mid-range sounds, well, like a sine wave. But the beauty of the original is, if you're going down the octaves, you're starting to hear beautiful digital quantization notes. And if you then start to use other waves in the wavetables, you hear all the rich spectrum of the original. So let's listen to this in the context of a sound. It's a simple sound. Which modulates the wavetable with an envelope. So this is a special Waldorf ASIC sound of the wavetables. And it cannot done with modern bass synthesizers because the oscillators just work differently. You would not do it this way today. So let's have another listen. Let's check this sound. And now this one. You hear the very brutal digital sound. So the original microwave was very much known to its brutal bass sounds. You have a very overtone-rich wavetable combined with the 8-bit quantization and all the aliasing. It gives you that typical 90s vibe of techno and hard bass sounds. Let's check another example. If you then get very snappy short envelopes, it sounds like this. So combined with these short envelopes and the overtone-rich digital hard wavetable sounds, that gives you a very percussive, very energetic sound. And so let's have a look on the filter. The Protein, of course, it's a full digital machine. So the filters are digital in contrast to the analog filter of the original. So let's listen to some filter sounds. Yeah, that guy. The default filter is a low-pass filter. We have a high-pass filter as well. Which the original, of course, did not have. We have, in addition, drive modes. So let's check an example for drive modes. And you hear a modulation which sounds like a wavetable modulation, but basically it's drive. So if you go to the filter page, you see here, I can switch to a drive, and the envelope modulation of the filter is now modulating the drive amount. So if I'm turning the envelope back, you hear the wavetable behind. If I'm turning up, you hear the timbre modulated by the drive. That's a drive within the voice. Meaning, if I'm playing a chord, I don't get the typical fuzzy distortion if you go with a chord through like a fuzz pedal. We have, and this is because you go with a chord. Here we go per voice. So the drive in the per voice, it's more a subtle tonal effect, timbral effect. We have, of course, in the master section, a drive effect to get this more distorted chord-based stuff. So it's just an alternative to the filter. You can employ a drive. We have, instead for the resonance, we have different drive types you can select, and the cutoff, it's basically the drive amount. In addition to the wavetable oscillators, we have also the noise generator, but also clicks, Geiger, crackling, and burst to add a little bit of timbre, exciters, and transients to the sounds. So let's try what this is. So there's a subtle wavetable in the background, so I'm adding white noise, which goes through a flanger to make it a little bit more funny. Let's do a crackle. Or a Geiger. Or just a click. Okay, the flanger makes more clicks than one click, so let's get the effects down. No effects. Now you hear the single click. Going back to the Geiger. It goes through the resonance of the filter, which is a beautiful effect. But if I'm dialing back the resonance and opening the filter, you hear the... In addition, we have bursts. You can add to the sound in addition to static white noise. So this is another sound design feature. And you may have recognized on the bottom right side a knob called flavour. So what is it? Let's go back and dial in an init sound. And if I'm adding the flavor, I'm adding micro variations, so I'm going back to no flavor. I'm adding some micro variation to the sound. This is not one-dimensional, so let's start with this sound here. So this is just an arpeggiator which repeats a note. And if I have no flavor, it's just digital and always the same. If I'm adding the flavor slowly, you hear some micro variation. In this case, it's the wave of the wavetable. But it's not just the wave of the wavetable, it's actually a mix of stuff. Let's try this. It does it now with a cutoff. Mechanic. A little bit more lively. And it's also doing this to the pitch, but only one oscillator and very subtle. So it will start to detune both oscillators. If I'm now adding flavor, I'm now have a little bit of a beating. But it's not a constant beating. I can dial in with the detune knob. It's micro variations. So the flavor is a way of adding to a pure digital synth some kind of micro variation, which makes the sound for some ears more pleasant to hear. And so we have, of course, an arpeggiator, because that's fun. Let's try this one. It's basically the arpeggiator from the Iridium and Quantum line. So you have all the features, all the parameters, you have rhythmical patterns and stuff, and you can do very cool sounds. There's also a sequencer, step sequencer with 32 steps. So let's listen to some sounds using this. So you can step record the steps, but also adding each individual step in the machine. And it goes also by using rhythmical patterns, so which is interesting. So that would be in sequence, using some rhythmical patterns. So let's modify the rhythmical pattern. If I'm going here to the sequencer page, this is without a pattern. Sounds a little bit mushy, too much going on. Now we have about, I think, 15 or 16 patterns. And combined with some kind of delay, which is also synced to tempo, you can get interesting stuff going on there. And another interesting feature is we have scale-based transpositions. So in the normal mode, whatever key you press would chromatically transpose your sequence. But it can be snapped to a grid. So let's choose this one. And if I'm looking onto the sequencer page, wait, let's keep this back. I see, okay, it's done chromatically, but I could just put it to a grid like whole tone scale. And regardless which note I'm pressing, it will match all notes to the whole tone scale, which is kind of fun. You can also do some more pentatonic things. Or you just go back to chromatic. So this is a scale-based sequencer. And I said in the beginning, the synthesizer is polyphonic with 8 voices, but we have 4 layers. So if you look in modern synthesizers, the voices over the years got more complex. So sonic complexity is arrived while having a complex voice. You have 3 oscillators, sometimes even more. You have 2 or more filters. You have different routing options moving, some oscillators and this filters, etc. And it's get very complicated. It's very flexible, but only the most experienced sound designer would use all those complex stuff. It turns out it's very hard to use. Looking back to the original microwave, the microwave had a very simple principle that the voice itself, it's very simple, 2 oscillators, 1 filter, that's it, and a VCA, of course, and the modulators. But you can achieve sonic complexity by using multiple sounds and simple voices stacked around robin in round robin mode or with MIDI split together. So let's see. And that would be a sound which is a little bit more complex. A bass sound. And it's actually 3 sounds stacked together. So if I'm switching off the multi-mode and going back to single layers, that's this first sound. The second one, the B layer, would be more subtle bass added. The third one, it's another percussive transient. So if I'm going to multi and layer all together, it would sound like this. So it can be done in a very quick mode to create this layer stuff. So let's have another example. Let's go for this guy. And decompose it. First layer, second layer, third layer. In fact, each preset, even not in multi-mode, has all the sounds of the 4 layers. So what I'm doing right now is I have 3 different sounds without even changing the preset. So that's a little bit of a positive side effect, having a 4-layer system. I do not need to use them in a multi-layer mode. The funny thing is I can recombine stuff very quickly. So let's go for an init sound. So I'm in the layer screen. I'm loading layer. Let's get for this sound. So I can load in a specific layer from all the presets in the system, individual layers. So I'm going now to multi-layered. I'm activating the second layer and load another thing. So let's go for this guy. Let's listen to them separately. It's a plug, so I'm adding a little bit of transients. Let's get another one. And let's get this guy. I can now start to adjust the volume of each and individual layer. I can also, for each layer, set the effects routing. So we have 2 effects for the whole machine, and each layer can be individually routed into one effect, the other effect, or no effect at all. There's also a mode where I can go to mono and legato modes and polyphonic mode, the standard stuff you're getting. But there's also some fun stuff. So if we are getting back to the sequence we heard already, you hear that each note has a different timbre. And this is because we are in a multi-mode here, which is called round robin. So if I'm deactivating the sequencer for a moment, and I'm just playing notes, I'm just going through all the layers. That could be also done in a random fashion. If I would layer them together, it would sound like this. But it's kind of fun to have them in this sequence style. There's another mode called midi split, because some people want to play different timbres from different MIDI channels running from the sequencer or different controllers or whatever. So that's a MIDI split node. So you can just trigger all the 4 layers from different MIDI channels if that's what you want. So let's move on. There's another interesting feature which is called the chord mode. The chord mode, it's a way to play chords. So let's try this sound. And as you hear, it's not just the sound transposed, because we have a similar system, like with the sequencer, with the chords. So if I'm here now, I'm in a scale-based chord mode, where I have a C major pentatonic scale with a chord comprised from the 1st, 3rd, and 5th step of the note I'm just playing within that scale. If I'm going back to, let's say, free mode, then we just have a transposing. Let's just go for major chords. Or minor chords. Or all the different, all the different chords we have here. I'm a left-hander, so I'm always hiding the display. I'm sorry for that, but human nature is the way it is. So that's the chord mode. The protein has an effects section with 2 effect slots, and we have effects like chorus, flanger, phaser, tremolo, drive, multiband EQ, delay, and reverb. In fact, the effects from Quantum Iridium, but instead of having 5 slots, here you have 2 slots, because it's a much smaller machine and it's much more portable and affordable. But you have the full parameter set, which gives you lots of possibilities In terms of presets, we have up to 250 slots. We will deliver the instruments with over 200 factory presets. You can immediately delete them and do your own stuff, but you can also choose those as starting points for your own sonic endeavors. You can, of course, categorize them and filter by categories, and you would import and export via MIDI sysax. And just running a little bit through the feature sheet here, we have a modulation matrix with 8 slots. We have 3 envelopes for the wave table, for the filter, and for the VCA. But of course, you can use the envelopes in any combinations in the matrix. We have 2 LFOs. Those are, of course, syncable. And you can clock it to external clock sources like your DAW or some other generator. We have MPE support. You can use the per node pitch band, the Y-axis in a polyphonic way, and of course the polyphonic aftertouch as well. We have modulation sources like random, release velocity, assignable, MIDI, CCs, and a whole lot. All the instruments, all the parameters can be MIDI CC learned, so you can automate it from your DAW, or you can, of course, use any other controller using MIDI CCs. The firmware updates are very easy. You just connect the protein to the computer and it goes within 30 seconds. You apply a little file to the system and it's very quick and easy. So we are very proud of the new instrument. We will release it on Thanksgiving 2025. It's in Berlin with a little concert and an artist, Savoloka, is playing. It's a fun instrument. It's really deep. It's very affordable. You will be astonished. And it has the heart and soul of Waldorf. So make some great music. Thank you and bye-bye.